Welcome to part 2 of chapter 2 on quality management. And in this case, we will continue our discussion on quality management from an employee perspective. And in this case, role of employees in quality improvement typically takes the form of collaborative or participative problem solving. And typically in this case, employees actually are not just hired to produce a product, but also work smarter in terms of being a collaborative entity in decision making when it comes to quality. So they are heavily involved in quality management. Every employee has undergone extensive training to provide quality services, and this is rather obvious in case of Disney company, where every Disney guest, every customer of Disney which is considered a guest, can receive good customer service from the employees who actually have gone through extensive training. Another term that is used often in quality management is Kaizen. Kaizen is a Japanese word which represents Kai, which is change, and Zen, which is improvement on a continual basis. So continuous quality improvement, ever changing to improve quality. And the idea behind Kaizen is involving everybody in the organization so that they can identify room to improve even if it's a small steps, baby steps to improve the quality, that can be easily addressed with everybody involved. The quality improvement efforts do not take that much time. So employees determine solutions on their own problems, any minor adjustments, and they have the authority to implement those changes so as to do their job better, so as to provide better customer service, or to make the product better, improve the quality of the product or the production system, if you will. And a related topic in this area is, as it relates to employees in quality management, is quality circles. It originally was forwarded by Ishikawa, one of the quality gurus in Japan, which is something used even to this day extensively in Japanese organizations. Quality circles is a voluntary group of workers and supervisors who get together on a periodic basis to discuss all the happenings of their shift, what's going on in the production process, how the product is being produced, any issues related to quality, work environment, which may affect the product quality in one form or the other, that can be addressed. And in this case, you can notice that a typical organization of a quality circle is about 8 to 10 members, same area, who all work in the same area, with a supervisor who is also familiar with that area. And they actually undergo some training of how to discuss, almost like a brainstorming session, of how to better discuss the aspects of what quality problems they're facing and how to come up with creative solutions around it. Problem identification is the next step that they go through, where they identify or list alternatives, and then based on what is suggested, the team goes through a consensus process where, based on what majority says is the right way to fix those problems, after brainstorming a variety of ideas. That is where other quality tools that we discussed earlier are included. Those include cause and effect diagram, various data collection tools, and data analysis tools are also used that were outlined earlier. Then, based on the discussion, solutions are identified for a particular problem, and then final presentation of how to implement such a solution, and after implementation, monitoring of those in seeing if the intended results have been achieved. So that circle pretty much is very similar to plan, do, check, act, but in this case, a group of employees are involved rather than somebody, and they're focusing on a very specific production process that everybody's familiar to within their own department or within a particular machine group area, etc. And so similar concepts, process improvement teams can be used throughout the company. What quality circles do for one particular department can be actually taken throughout the entire company, and typically organizations can create process improvement teams which actually have, and the idea behind this is to focus attention on business processes that the entire organization is dealing with rather than just one specific department. And it includes members from interrelated departments, so it could be marketing, operations, finance, anybody who is affected by the business improvement initiative would be involved in this. So typically many of these are considered under project teams, but focusing on improving quality. It's important to understand the process that the team is addressing so they can identify the right alternatives in this area. And typically, they end up using process flowcharts to help analyze what the problems are and how to identify solutions. Now, in terms of quality in services, service defects are not always easy to measure because service output is not necessarily a absolutely tangible item. Many service components are intangible, as was discussed earlier. So another aspect of services is it's pretty labor intensive. And given that aspect of it, it tends to have a little bit more variability in terms of quality because each person which is delivering service and at the same time the customer who is also tends to be human and who is receiving service, it's in their mind as to what type of service they have received. So the quality assessment becomes a bit subjective. So that intangibility makes it harder to actually measure the defects of quality on an absolute basis. So service and manufacturing companies have similar inputs, but their outputs tend to be rather different because of what all is being received as part of service is different. When you're buying a product, it's just the product, the physical goods. But when you're receiving a service or a customer for a service, that's a service package which may include some tangible aspect of goods that you receive, plus the service part of it, the intangible part. And in terms of quality attributes in services, so in this case, principles of TQM equally apply to services, but more importantly, timeliness is a big key criteria. If the service is not provided at the right time, then the quality perception is that it's not the best possible service, regardless of how good the tangible component of service is. Even if you provide good product, which is comprised in the service, but if it comes at the wrong time, it may not be considered as a good service. It's like going to a restaurant and ordering food, and you may somebody makes the best possible meal, but if they are an hour late in delivering that meal, the customer may not be happy about the service they received, regardless of how good the food was. So in this case, one way to do that is measure the quality in services to benchmark the service that you're providing and against the best in that category with other companies. So next, we look into the area of Six Sigma quality. And in this case, it's a philosophy and set of methods companies use to eliminate defects in the product and processes. So this is a concept which actually, developing and delivering virtually perfect products and services because it's a measure of how a process deviates from perfection. So what we're really focusing on is a process that is evolved from the total quality management area into really arriving at virtually perfect quality. Goal here is 3.4 defects per million, which is considerably, minuscule as compared to what traditional quality was accepted in the past. So this is 3.4 defects per million opportunities, or in short, DPMO. Typically, adopters of Six Sigma have been General Motors. Motorola is among a significant company that has institutionalized it throughout their organization. And methodologies to understand and achieve what the customer really wants and deliver that. Seek to reduce variation in the process that leads to the defect. So in this case, what the focus is 3 group expectations to define critical success processes required performance levels. So over here, what we try to focus on is customers, which include clients, your initial customers, plus the end consumers, management shareholders, what do they want, as well as the employees. So Six Sigma typically uses voices, which is feedback from these groups to identify the critical success points in this case. These voices are the voice of the customer, voice of the business, which is management and shareholders, as well as the voice or the process, which is the what is capable of being done within the company by the machines, by the infrastructure that they have, by the money available, budget available, etc., from the employees, and then voice, and finally the voice of employees, which is what employees are able to indicate as to how to minimize variation and improve quality. So in this case, Six Sigma processes typically is to align, your process through a balanced scorecard that we discussed in the previous part. Mobilize project teams that we'll discuss a bit later, and accelerate, which is Brack and Griegelt execute the project. And in this case, if I were to just jump over here, tell you about black belts and green belt. Black belt are the project leaders in Six Sigma initiative, whereas and in this case, master black belt would be somebody who actually can teach a black belt Six Sigma expert, and they serve as mentors so that they can advise the person who's leading a Six Sigma initiative, the black belt, and then guide them in making sure their initiative is a successful one. And the green belts are project team members who are working under a project leader, the black belt project leader, to make sure to see this Six Sigma project through. Coming back to after the black and green belt execute the project, the governance is being done by monitoring and reviewing project where master black belts are involved, and then champion and executive responsible project success, which typically could not be just the master black belt, but also the company executive, which is the stakeholder, the champion for such initiative. And in this case, you have variety of Six Sigma initiatives. One most common example that you come across is the Six Sigma project initiative that's called DMAIC, which is define, measure, analyze, improve, and control, which is used, that cycle is used for existing processes that are already within the company, and existing product improvements. So these are only for existing processes as well as existing products. So in this case, define is customer and their priorities. So you identify what customers really would like, and measure the process and its performance, analyze the cause of defects, improve, which means remove those defect causes, and control, maintain quality in this case. So in this case, one can easily see the Six Sigma process the DMAIC, where the champion is giving advice, mentoring the black belt about what needs to be done. And then black belt, who is the project leader, needs to work with the project team members, the green belts, about what all has, how the process is defined and what needs to be done. And this is where the green belts would go out, the project team members, and measure the various aspects of the process to see what needs to be accomplished and analyze it, and then try to identify the variability in the process and then improve that so that you are down to 3.4 instances per million opportunities, which is almost virtually perfect product. And then once that improvement is implemented, make sure it is controlled and it's stable. And then once this is done, that's where the improvement has been accomplished. And over time, these black belts, the project managers, have to go through on a continuous improvement aspect, go through training through the master black belt to see how else they can improve or seek out or lead Six Sigma projects in the future. So that's an example of that. Now let's look at slightly a different type of Six Sigma initiative, which is actually used for new services and products. Earlier we talked about DMAIC, which was for existing processes and products. This is for new service product design. And so normally most business majors, if at all they are involved in a Six Sigma project, that will be of DMAIC nature. But in new product development area, you do come across DMADV, which is define, measure, analyze, design, and verify. In this case, the design, measure, analyze is exactly the same, where you define customer priorities, measure the process and improvement, analyze the causes of defect, and then rather than IC, now you're doing the DV, which is design the new product and then verify whether design is effective. So that's the only difference in this case. Let's move on to our discussion of Six Sigma tools that are used. And one most important tool is the quality function deployment, which is also known as the House of Quality, which is a tool which we'll cover in later chapters, focuses on how to actually collect effectively the feedback from the customer, also known as the voice of the customer. And then cause and effect matrix, which we discussed earlier in chapter 2, looks at identifying and prioritizing causes of a problem. Failure mode and effect analysis, this is a very valuable tool from reliability engineering field that actually gets used to identify what are the potential problems and identifying them before they even happen so that we can have a contingency plan set up for them. T-test is used to identify if there is inherent differences, significant differences between two set of measurements. And statistical process control charts, which we'll be covering in detail in a subsequent chapter, are also used to monitor the process to identify variations. And then to implement best practices, design of experiment is used to identify what are the best inputs, combination of inputs to achieve outputs in this right type of outputs. Design for Six Sigma and profitability. When you look at design for Six Sigma, it's a systematic approach in designing products and processes that will achieve Six Sigma. So you're designing a product in a way or a process in a way that it will give you Six Sigma results, which is near perfect results. So use the same basic approach as breakthrough strategy, employs the strategy upfront and design and development phases. This is exactly the DMADV approach, and more effective and less expensive than way to achieve Six Sigma if you were to do it right from the start rather than implementing it in existing products and services. Profitability wise, typical criteria, the company should stay profitable is one of the key criteria for Six Sigma projects. You cannot have a Six Sigma project which will lead to bankruptcy or actually having a loss in financial loss in one of the companies. Because one of the key aspects that you incorporate in Six Sigma projects is the voice of the management, which is shareholders, etc. And one of the factors distinguishing Six Sigma from TQM. In TQM efforts, there is no clear-cut relation with profitability, but it is there with Six Sigma initiatives. So quality is not only free, it's an honest to everything profit maker. So that's one of the key tenets of Six Sigma. That is, if we pursue quality, profits should eventually be one of the outcomes, natural outcomes of that. You cannot have a trade-off in producing quality and having a loss. Quality improvements reduce cost of poor quality and thereby improving your bottom line. Another aspect is another practice in Six Sigma is the Lean Six Sigma, that is actually producing Six Sigma, initiating Six Sigma projects, but with the lean principles, which is without actually implementing too much inventory or waste. So in this case, you integrate Six Sigma with lean system, which we'll cover lean systems in a later chapter, and lean principles seek to optimize process flows so that there is very little waste throughout the system, extends earlier effort in efficiency, and then lean processes, typically the improvement steps are to determine what creates value for the customer, identify the value stream, so focusing on things that actually add value and which typically would reduce variability, remove waste, make process responsive, and continually repeat attempts to remove waste. And then in this case, both these continuously seek to improve the process and increase value to customers. So even their approach to goal is different, but they complement each other rather well. So let's look at an example of Six Sigma and how it impacts the cost. So we have a company which implements Six Sigma to reduce defects from 10% to 0%, and they spend in a year $120,000, which comes out to be about $10,000 a month, done for 12 months. So in this case, you have a company with $1 million sales. Originally, variable cost is $600,000, and the fixed cost, which is variable cost, is related to the material used, and a lot of this cost is product spoilage or defects that are being produced in the current process, and not only just the cost of goods sold. And then remaining fixed cost is maybe renting the space, wages, employee wages, etc., that is going in here. And then from this, these two costs added together gives you $950,000. When subtracted from 1 million, gives you a profit of 50,000. Okay? And in terms of after changes, what you're looking at is $1 million, and this is not taking into account the cost associated with Six Sigma. So, but now, when you reduce your defects from 10% to 0%, your variable cost goes down. So that is a reduction all the way to 540,054 is the new cost, which is, I believe, if you take 600 divided by 0.9, that will give you times 0.9 is the number that is arriving at in this case. And given this, so your variable cost goes down, and then you have fixed cost remains the same, but this total, the new total cost is much lower. So 1 million minus the 890, you're looking at $109,000 profit, which is almost doubled. But after adjusting for Six Sigma cost, which is, as I mentioned earlier, $10,000 addition a month, in the fixed cost category. So it just jumps up to from 350 to 360. So you're looking at now the new profit after adjusting for cost is 99,946. So in this case, you can see what you are doing is spending 120,000 in the for more changes. So given this changes, what you have is the new profit increases 99,946 minus 50,000. That's 49,946. Subtracted the 10,000 that the Six Sigma cost, and once you take that divided by 120, and you get a return of 33% on this number, which is a pretty significant return in this case. Now, since quality has been associated, has been established that quality has impact on the bottom line cost of the product, we'll look into what are the various costs of quality. As Philip Crosby, one of the quality gurus, has mentioned, quality is free. That means there is no cost in producing best quality first time around, but there are still costs of producing poor quality or ensuring the quality that has been produced is good. So in this case, there are 4 different types of costs. 2 come under the category of ensuring that we are producing good quality, and the other 2 costs are the cost associated with actually producing defective or poor quality. So under the good quality, you have prevention cost, which is cost of making sure this is the cost which is incurred during product design before the product has ever been produced. How to train the employees, how to revise the design, how to improve the processes, as well as the second type of cost is appraisal cost, which is cost of measuring, inspecting to make sure whatever we are producing is a good quality or bad quality. Then in terms of poor quality, this is where actually a defective product has been produced. A poor quality product has been produced. So there are 2 different costs associated with that. The only difference between these 2 is whether or not customer knows about it. If the customer does not know about it, we produced a defective product and we caught that before it ever reaches in the hand of the customer. That's internal failure. It includes scrap, rework, process failure, downtime, and price reduction. If you buy clothes at an outlet mall, a lot of them may be available at a significant discount, and many of them may indicate irregular products. So for example, so those will be all the price reduction in this case for poor quality. Second-hand items or last year's model, whatever it is. Then external failure, this is where customer actually was sold the product, and that's when they discovered the quality of the product is poor, and that's where include complaints, returns, warranty claims, liabilities, etc. To get into more details for these costs, looking at prevention cost, this includes quality planning cost, product design improvement cost, improving the process, cost related to that, training of the employees, and improving information delivery in the whole quality improvements. In the appraisal category, you have inspection and testing, as I mentioned earlier. Also, what is the cost of operator to spend time on inspection, as well as cost of test equipment. The crash test dummies that are used to test the integrity of the vehicle during impact, when you actually end up consuming, if the car is no longer saleable, but even though it was perfectly fine, that still will come under appraisal cost, because that is the cost of testing. Then you have the cost of producing poor quality, and this is the internal failure cost. That's scrap, rework, process failure, something, the machine broke down in the middle and started producing out of spec parts, products. Process downtime, or the refrigerator shuts down because of some malfunction and the food inside spoils. So that's all example of process downtime in a restaurant, for example. Price downgrading that we mentioned earlier. And then you have external failure, where you have customer complaints, product return cost, warranty claims, product liability, lost sale, which is typically hard to measure, the bad word of mouth. If a customer is unhappy, they'll go out and tell 15 other people about, or many other people about how bad this particular service establishment or product company is. And that bad word of mouth travels very quick. Some examples of that, you see that in Yelp, where customers typically review various product and service companies. So it's hard to measure that and control that in most cases. So when you measure these quality costs and report them, so typically various ways of measuring them is index numbers. We always can measure quality cost against some base value, how much you have been, what is the standard for a particular type, and how much you are spending. So that way you know if what you're spending on fixing defects, on fixing warranty claims, or fixing customer satisfaction requests, or doing inspections, is that consistent with what the industry is spending, or your costs are out of control. That means you need to improve the process somehow. You could compare across a ratio of quality cost to labor hours. That's another index that can be created. Or cost index, which is quality cost to manufacturing cost. Ratio of quality cost to sales, or quality cost to the number of units of final products that is produced. Quality cost relationship, cost of quality, this typically is the difference between price of non-conformance of producing defects and versus producing defect-free products. When the cost of doing things wrong actually is 20 to 35% of the revenues. Whereas if you do things right, that is by improving, your cost of, it only takes about 3 to 4% of revenue. So it makes financial sense to invest in sound or better production processes, or revising the design, spending very little but saving a lot more in the process. Okay? So here is an example, a numerical example of how cost of quality can be looked at, and you can see over time, companies should be reducing their failure cost as they progress if they are on improving themselves. You can see the maximum improvement will be in external failure, because that's the one you really want to, companies typically have their external failure, most of their external failure early on when they just get started. But as they get their quality improvement processes in place, you'll see that external failure reducing significantly, almost gone from 242 to 103 or so. And then internal failure, it may fluctuate, but you can see eventually it also should come down as the design improvements are implemented. And the appraisal should be also going down, but at a lesser pace. But you can see from 155 all the way to 107, what should go up is prevention costs, because a company over time should be investing more in training and systems which actually help you revise the processes, or revise, because by this investment you are reducing all the other numbers. So that's where you see the significant reduction. And you can compare this with how your sales are doing over time. That you can see you tend to sell more as the quality improves, because now your total cost has significantly dropped from 810,000, not to mention bad word of mouth, etc., to 544. And you can see the manufacturing cost is pretty much in that same area. So you are actually selling more from your cost has not gone up significantly, but sales have gone up. And most of those sales are being translated from the product that did not become defective in this case. So if you were to compare this, you can easily look at the quality index, and you can see those four numbers, 810,400, which is right here. And for 2006, you can add up the 4 years. You can see you have a 18.58 is the base. And that 18.58, it does go to 18.63, but then it drops to 1266 and 1049, which is actually improvement. So you can see significant improvement coming as the years progress. And the same thing is being shown in the quality manufacturing cost index, which is gone from 46 all the way to 28.8. So that's a way to kind of quantify the cost improvement in quality investment over time. Let's go ahead and look at effect of quality management on productivity. And in this case, productivity, which is typically output over input, and a quality impact on productivity, which is fewer defects, increase output, and quality improvements reduce input that you see. And one of the things, terms that is used a lot in this area is yield, which is a measure of productivity. So how we measure yield and productivity is total inputs times percentage of good units that is being produced. So all the input that is spent in there, and what is of this, how much was produced that was good, and plus what was 1 minus percentage good units, the remainder of the units that were not good, and what percentage of that were worked. So that will give you the yield. That is, so in this particular case, that's the formula. And let me show you how to use this formula, how to compute product yield. So in this case, if you look at a motor manufacturer, which starts with a batch of 100 motors, 80% are good when produced. So that's the 100 motors. Out of them, 80 are good. So 100 times 0.8 will give you the 80 motors that were good the first time around. And of the remaining 20 motors, which is 1 times 0.8 is 0.20 times 100 is the 20 motors that were not good. Of them, 50% of the defective motors can be reworked. So they can be fixed, repaired, and be made available for sale. So 50% of 20 is 10. So 80 plus 10 is 90 motors altogether. So if we are able to institute quality improvements so that we are producing 90% instead of 80% good the first time around, what you can see is the yield will drastically go up from 90, which is earlier case, to now 90 being produced first time, and the remainder 10, 5 of them can be reworked, which is 90 plus 5 is 95. So you can easily increase your yield by 5 motors, which means 5 additional units available for sale. So that definitely, and the same thing can be applied if you are computing product cost per unit. But these are all the ways of actually finding or actually quantifying the cost and yield associated with the quality improvement. So computing product cost per unit in this case is direct manufacturing cost times the input that you used, and then rework cost of the reworked unit divided by yield. So in terms of product cost, how much cost of goods sold, so one of the numbers that you need is the cost per unit. And in this case, when you look at direct cost is $30, and 80% is good, and rework cost is $12, which is added on to it, and then 50% can be reworked. So notice that you have a total of 90 motors, and that is coming in the yield. If you look at the previous example that I showed you, in this example, you have 90 motors which are coming in the first case, and then 95 motor yield in the improved case. So let's go ahead and look at this. So in the first case, you have $30 spent on the total 100 that you had, and $10 100 motors. So $30 per motor times 100 motors, that's $3,000, plus $12 on 10 motors. That was the cost spent on reworking. divided by the total yield, which is 90. And that comes out to be you're actually spending $34. That now you're still spending $30 direct cost on the 100 motors, but now you're only spending $12 additional only on 5 motors instead of 10 motors. And then yield now is 12. So this drastically reduces your cost per unit, which is to $32.21. And so that actually makes the case for actually implementing quality in an organization which has not invested in it. So same thing can be easily extended by looking at the formula over here to multi-stage process where you are actually going through several stages. And you can easily follow this example to actually find the yield in this case. So multi-stage yield in this case is if you're going through 4 different stages and in the first stage, 93% come out to be good, remainder are bad. In the second stage, 95% good. Third stage is 97% good, and fourth stage is 92%. The yield in this case of 100 motors, which are going through all the 4 stages, will be 100 times 0.93 times 0.95 times 0.97 times 0.92, which you add up altogether is 78.8 motors. So in that particular case, say initial batch of 100 motors, you can see you can actually receive about 127 motors in this particular case. Now quality productivity ratio, which again can be calculated in this case, just to show you quality of good units divided by input times processing cost plus reworked unit times rework cost. So in this case, that number, as we calculated earlier in the numerator, now it's in the denominator. So you have direct cost of $30, 80% good, initial batch size of 100, and then $12 is the rework cost, 50% is reworked. So in this case, 80 plus 10 is the numbers that you have. And in this case, the base case, you're looking at 2.89, which is quality productivity ratio. And whereas if you increase the yield to 200, initial batch size to 200, what you're looking at is still no changes because you have the quality productivity ratio is not impacted by the batch size. That is, the more you're producing, you're getting now 160, which is 80% good in the first time, and 20, which is remainder 40 motors. Of that, 50% is 20. So everything is just being doubled, which is 80 is being doubled to 160, 10 is being doubled to 20, and then this 100 is being doubled to 200, and then this 10 is being doubled to 20. So numbers still come out to be exactly the same. But if you change the scenario to reduce the direct cost to 26 and rework cost to 10, now you'll notice that everything else remains same with the base case except for these 2 numbers that are different. And if these are reducing, that will increase the quality productivity ratio. Whereas if you increase the percentage good to 95%, you can see from 80 to 95%, that also improves the quality productivity ratio that in essence, which is measuring how good the quality is. The higher the number, the better. If decrease the cost and increase the percentage good, you can see now the number has gone even higher. So then again, it just is a way to quantify how quality improves your bottom line or reduces your cost. Now let's talk about the quality awards related to quality management that are given out in the industry. And the most common one that is given out is the Malcolm Baldrige Award, which was created in 1987 to stimulate growth of quality management in the United States. This is equivalent of the industry Oscars in the United States. One award is given out in each category for the large company, one for small company, one for services, etc., or education. And the categories in this area are leadership, information analysis, strategic planning, human resource focus, process management, business result, and customer and market focus. This award, typically only the leader in each in category gets one award, just like an Oscar. Not everybody does not get an Oscar. Same way, every company does not end up receiving an award. So it all depends on which company puts the best foot forward in a given year in those categories. Compared to that, there are other awards for quality all over. So you have national individual awards, which is Armand Feigenbaum Medal. Deming Medal is also instituted in Japan, as is Ishikawa Medal. And then you have Lancaster Medal, Edward Medal, Shewart Medal. So there are several awards that are actually, on the national level, but on an individual basis. Then they have international award, which is European Quality Award, which is given throughout Europe, which is equivalent of European Oscars, if you will. Canadian Quality Award, same thing, a national award just in that category. Australian Business Excellence Award, which is similar, but now for the Australia region. And then Deming Prize, which is given out as equivalent of Malcolm Baldrige, but for Japan. And now comparing this to ISO 9000, while only one company may win our Malcolm Baldrige Award, any company that meets the minimum qualification can receive ISO 9000 certification for quality management. So these are procedures and policies for international quality certification. So for example, in 2008, version of ISO 9000, those are the quality management system, fundamental and vocabulary that provides you the roadmap for going through the process, defines fundamental terms and definitions used for ISO 9000 family. Many overseas companies but will not do business with supplier unless has ISO 9000 certification. So it uses ISO 9000 accreditation and ISO registrars, which is companies that are designated to evaluate and then provide the certificate of compliance. ISO 9001 is the highest standard within ISO 9000 category, which is all the requirements, standards to assess ability to achieve customer satisfaction, and typically only standard that carries third-party certification. So you need an outside evaluator to come in and evaluate whether or not you're certified. And in this particular case, and if I may look into, give you an example, ISO 9001 is the highest standard. So there are other standards, which is ISO 9002, which is small, for a smaller subset, and ISO 9003, which is even smaller. So a company that is ISO 9003 certified, that only certifies that they offer quality in their systems which are related to repair and after sales implementation. Whereas ISO 9000 will be focusing on after sales implementation, repair, plus the manufacture. And then ISO 9000 is also including design, manufacture, and after sales and after sales. So that's why ISO 9000 already includes ISO 9002, and ISO 9002 already includes ISO 9003. So this is the most comprehensive ISO 9000. If any company has ISO 9001, that is the most comprehensive, which automatically includes these two certifications in it. Okay, and the ISO 9004 is the guidelines for performance improvement, which is typically our roadmap of how to do it. ISO 9000 is also used for service companies for continuous improvement of quality management system. In the contrasting ISO 9000 with Baldrige Award is where companies will get extensive feedback from evaluators, even if they don't win it. Even if they win it, they'll get extensive feedback as to how they can improve things next time. Whereas from ISO 9000 third-party certifiers, they will only know whether they received the certification or they did not. They will not get any feedback. One of the key differences between ISO 9000 and Malcolm Baldrige Award is the Malcolm Baldrige Award is focusing on providing feedback, extensive feedback from inspectors who are evaluators of Malcolm Baldrige applications. So they will provide extensive feedback in case the company goes through the various stages and provide them feedback whether or not where companies can improve their processes. Whereas in ISO 9000, they will only find out if they receive the certification or not. It's very similar to getting a bachelor's degree. You either get the degree or you don't. But anybody can qualify for that degree. Same way, any company can qualify for ISO 9000. But not everybody will get the Malcolm Baldrige Award. Okay, so that's the difference, and that pretty much wraps up our discussion for Chapter 2, Quality Management. And we'll see you for our discussion of future topics.